Cauchy's theorem. If a function f of z is analytic and it is derivative f dash of z is continuous at all points inside and on a simple closed curve C, then we can write integral over C f of z dz equal to 0. Cauchy's integral theorem is if f of z is analytic inside and on a closed curve C of a simple closed connected region R and f small letter a is any point within C, then f of a equal to 1 by 2 pi I integral over C f of z by z minus a dz. The integration around C being taken in the positive direction. This is Cauchy's integral equation. That is f of a equal to 1 by 2 pi I integral over C f of z divided by z minus a dz. Cauchy's integral formula is a fundamental tool in complex analysis used to calculate complex integrals, determine analyticity and solve difficult real valued integrals using contour integration. It is very used in signal processing, means it is used in filter design and to extract instantaneous phase and amplitude in communication signals. It is also used in image processing. It aids in its deduction through analytic signal reconstruction. That is, it very used in image processing. It is also used in physics and engineering. It facilitates contour deformation in quantum mechanics and helps analyze energy level and decay rates. It determines the radius of convergence of power series and its return for evaluating inverse Laplace transforms. It specifically solves integrals of meromorphic functions which are critical in complex system engineering. It is very used in our real life problem solving. So we state this Cauchy's integral formula is f of a equal to 1 by 2 pi I integral over C f of z whole divided by z minus a dz. This implies we can write integral over C f of z divided by z minus a dz. That is equal to 2 pi I into f of a. Given is integral over C sin pi z square plus cos pi z square divided by z minus 1 into z minus 2 dz, where C is modulus z equal to 3. Modulus z equal to 3 means modulus z equal to 3 means already we know that z equal to x plus iy. So modulus z equal to modulus of x plus iy, that is equal to x square plus y square. Already we know that modulus z equal to x square plus y square. Here this x square plus y square is equal to 3 because modulus z equal to 3. Modulus z equal to 3. So x square plus y square equal to 3. It can be written as x minus 0 the whole square plus y minus 0 the whole square equal to 3. That is Here 0 comma 0 is a center and radius equal to r equal to 3. Radius is 3. So that we can draw this graph. This point is already we know that this is 0 comma 0. This is point O. So we can write 0 comma 0 is a center and 3 is a radius. So that we can draw this graph. In this graph 3 is the radius, means in given problem the denominator term is z minus 1 and z minus 2. So consider z minus 1 equal to 0. This implies z minus 1 equal to z minus 1 equal to 0. This implies z equal to 1. Z equal to 1. This z equal to 1 means this point. In graph, this point z equal to 1. Similarly, in given function, denominator is z minus 2. So, we consider z minus 2 equal to 0. This implies z equal to 2. So, z equal to 2 in graph mentioned in this place. So, z equal to 2. It means modulus z equal to 3. The given point z minus 1 and z minus 2. That means z equal to 1 and z equal to 2 lies inside modulus z equal to 3. Z equal to 1 and z equal to 2 lies inside modulus z equal to 3. So that consider here f of z equal to given function numerator term sin pi z square plus cos pi z square. Sin pi z square plus cos pi z square. Substitute the value z equal to 1. We get f of 1 equal to sin pi 1. Sin pi 1 square plus cos pi 1 square. Z is 1. So that 1 square. So sin n pi plus sin pi plus cos pi. F of 1 equal to sin pi plus cos pi. Already we know that sin pi value is 0. Already we know that sin n pi value is 0. So here sin pi is also 0. But cos n pi value is minus 1 whole power n. Here is cos pi is appeared. So cos pi means minus 1 whole power 1 equal to 1. So cos pi value is 1. So substitute here f of 1 equal to 0 plus of minus 1 equal to minus 1. Suppose we put z equal to 2 because in given denominator term z minus 2. So that we put here z equal to 2. And then find the f of 2 sin pi into 2 square plus cos pi into 2 square equal to sin 4 pi plus cos 4 pi. Already we know that sin n pi equal to 0. So sin 4 pi is also 0. And cos 4 pi value is minus 1 whole power 4. That means 4 is a even number. Minus 1 into minus 1 into minus 1 into minus 1 is 1. So it is a positive value 1. So that we get here f of 2 value is 1. So here z equal to 1 lies inside modulus z equal to 3. So we can find f of 1 value. and z equal to 2 lies inside modulus z equal to 3, so that we can find the f of 2, its value is 1. Next we consider the function 1 divided by z minus 1 into z minus 2 using partial fraction. Using partial fraction, we can write a divided by z minus 1 plus b divided by z minus 2. In RHS, a divided by z minus 1. So, we multiply z minus 2 on numerator and denominator term. So, we get a into z minus 2 divided by z minus 1 into z minus 2. B into multiply z minus 1. So, we get z minus 2 into z minus 1. So, the denominator is common. So, we can add the numerator term. So, we get the RHS is a into z minus 2 plus b into z minus 1 divided by z minus 1 into z minus 2. Here the LHS and RHS, the denominator term is common. So, we can cancel it. So, the numerator term is 1 equal to a into z minus 2 plus b into z minus 2. Consider this as star equation. Then we put z equal to 2 and z equal to 1 in star equation. We get the value b equal to 1 and a equal to minus 1. So that 1 divided by z minus 1 and z minus 2 equal to minus 1 divided by z minus 1 plus 1 divided by z minus 2. Substitute the a value, b value in particular place, we get this result. So we have to find the integral over c sin pi z square plus cos pi z square divided by z minus 1 into z minus 2 dz. That is equal to integral over c, taking integration on both sides of on this function 1 by z minus 1 into z minus 2 equal to minus 1 divided by z minus 1 plus 1 by z minus 2. Taking integration on both sides, and f of z is sin pi z square plus cos pi z square, and we have to find integral over c sin pi z square plus cos pi z square divided by z minus 1 to z minus 2 dz. It can be written as this term equal to integral over c minus 1 sin pi z square plus cos pi z square divided by z minus 1 dz plus integral over c sin pi z square plus cos pi z square divided by z minus 2 dz. Already we defined it is a numerator term as a f of z. So that this term equal to minus integral over c f of z by z minus 1 dz plus integral over c f of z by z minus 2 dz. We can write minus integral f of z by z minus 1 dz as minus 2 pi I into f of 1, because here using Cauchy's integral formula. It is beginning of this solution. So minus integral over c f of z by z minus 1 dz is minus 2 pi I into f of 1, and integral over c f of z divided by z minus 2 dz is 2 pi I into f of 2. Already we know that f of 1 is minus 1 and f of 2 is plus 1. Substitute in this place, we get minus 2 pi I into minus 1 plus 2 pi I into 1. We get 2 pi I plus 2 pi I equal to 4 pi I. So, the integration over c sin pi z square plus cos pi z square divided by z minus 1 z minus 2 dz equal to 4 pi I.